The last thing we're going to cover today is an evaluation of usage considerations to keep in mind when you want to apply ReentrantLock or you're thinking about applying ReentrantLock in practice. First thing to remember, ReentrantLock must be used via a fully bracketed protocol, which means that the thread that acquires the lock must be the one to release it. And the best way to do that is by using something called the scoped locking pattern. That was also something that I wrote many years ago, and that appears in the POSA 2 book, and you can also read about it here. And the way this works is that, as we've said many times before, no matter what happens, you unlock that lock even if an exception occurs. Now, the way this works in Java's built-in monitor objects is to use the scope of open curly brace, close curly brace in conjunction with the synchronized keyword. So you could have a synchronized statement like this, you can have a synchronized method like this, and then the scope of the lock acquisition release is dictated by the open curly brace, close curly brace. Of course, that's done by the compiler. It generates code to do that, but it uses the semantics of the scope, that's why it's called scope locking, in order to do this. This pattern is also very common in C++ and C#, using constructors and destructors, and the resource acquisition is initialization idiom. And those of you who are C++ developers, this is how you can write similar code to what Java does by using mutexes and lock guards. I won't dwell on that because it's not really a C++ class. ReentrantLock supports recursive mutex semantics, or reentrant mutex semantics, where the lock can be acquired multiple times by the same thread without deadlocking on itself. So this is basically a little state flow diagram that shows how things can be used in terms of the hold count or the lock count. The downside with the ReentrantLock, and why you should be careful using them unless you encapsulate them properly, is they can be tedious and error-prone to program due to various common traps and pitfalls. So much like with semaphores, if you hold a lock for a long time without needing it, then you're locking other threads out from getting anything useful done. So here we have some code where we acquire the lock, we do a bunch of things that don't involve the lock, and we unlock the lock. Well, since we were doing a bunch of stuff that didn't acquire the lock or require the lock, we've frozen everybody else out during that duration. Another common problem is to acquire a lock and then forget to release it. So if you go into this code, you acquire the lock, there's a critical section, you return before you unlock the lock, you've got big trouble. So again, that's why you want to use the try finally idiom in Java to make sure that you always unlock the lock, even if exceptions occur, or you return in some strange way. Another problem is to release a lock that was never acquired in the first place or has already been released. So if you have some weird code where you accidentally or intentionally comment out the lock or in some path through complicated control flow, fail to acquire the lock, and then you unlock it, that'll cause chaos and insanity, and that'll throw the illegal state monitor exception. Yet another problem, which of course is a big problem, which is the whole purpose of having these locks in the first place, is to access a resource in a critical section without acquiring a lock for it first, or after you release it. That was a problem in a number of people's solutions for assignment 1B for the spin lock hash map manager. You were accessing shared mutable state, things like the Palantir map, outside the context of where the spin lock had been acquired and released. So that was the thing I was commenting on in your code if you did that. And then another problem is to call lock within the try block. Don't call lock in the try block. If lock happens to throw an exception for some strange reason, then chaos and insanity will result because unlock will be trying to unlock a lock that was never fully created in the first place. So that's why I always tell you, move the lock to before the try, but put the unlock in the finally. And I realize that's a subtle thing, but it's important to remember how to do that. Okay, so that's the end of the Java ReentrantLock usage considerations.